All right, let's talk about something truly fascinating happening right now in our cosmic backyard. An object from another star system has shown up, and frankly, it's acting so weirdly that it's got scientists completely stumped. So let's get right into it. This isn't just some random space rock. It's behaving in ways that just defy any easy explanation. And it's forcing the scientific community to ask a really fundamental question. Are we looking at a very, very strange natural event, or could it be something else entirely? The object at the center of this whole mystery is called 3I/Atlas. Now, that 3I part is a huge deal. It means this is only the third interstellar object humanity has ever confirmed is visiting from another star system. To put that in perspective, before Oumuamua showed up in 2017, we had never seen one, not once. Then came 2I Borisov, and now this third guest, spotted by the Atlas Survey Telescope, is giving us our best look yet at one of these interstellar travelers, and what we're seeing is just plain strange. Because almost immediately after its discovery, astronomers realized 3I/Atlas wasn't playing by the rules. It started showing a whole cascade of weird behaviors that just didn't add up. I mean, the strange clues just started stacking up. First off, it's speeding up faster than gravity alone can account for. Something else is giving it a push. Second, its color is actually changing, becoming more and more blue, which is really unusual for a comet. Third, after it looped around the sun, it suddenly flared up to become 5 times brighter. And to top it all off, its chemical signature shows way more nickel than expected. Any one of these is odd, all of them together, it paints a really confusing picture. Okay, so that acceleration is the biggest clue. We're talking about non-gravitational acceleration. It's a fancy term, but it just means some force, besides the sun's gravity, is pushing this thing. For a comet, that's usually explained by outgassing. Ice on its surface turning to gas and shooting off like tiny rocket thrusters. But as we're about to see, that simple explanation, it runs into a massive problem. And here's where the numbers get absolutely wild. As 3I/Atlas got closer and closer to the sun, the amount of material it was shedding just skyrocketed by a factor of 6,000. It went from losing a few hundred kilograms a second to losing almost 2 million kilograms a second. That is a truly enormous amount of mass being blown off into space. And this leads us to the central puzzle, what scientists are calling the size paradox. Just look at these numbers. To produce that much gas and dust, calculations show the comet's core, its nucleus, would need to be huge, over 14 kilometers wide. But when the Hubble telescope actually measured it, the nucleus was tiny, only 1 to 2 kilometers across. It's physically too small to be producing this much material. It's like trying to get a fire hose blast out of a water pistol. The math just doesn't add up. So, how do you explain it? Well, Harvard astrophysicist Avi Loeb came up with a pretty dramatic solution. What if the object shattered? He proposed that if it broke into at least 16 pieces, the total surface area of all those fragments would be massive. More surface area means more ice gets vaporized by the sun, which could explain the powerful acceleration. For a little while, that seemed like a plausible answer. But then, new observations made things even more complicated. Instead of a chaotic cloud of debris you'd expect from something shattering, astronomers saw at least 7 highly structured jets. And even more bizarre, they saw an anti-tail, jets of material pointing directly towards the sun. That just completely defies the physics of a normal comet tail, which always points away from the sun. This simple comparison shows the problem perfectly. A normal comet breakup creates a messy, diffuse cloud. What we're seeing from 3I/Atlas are organized, almost geometric streams of material. This just isn't what a simple natural explosion is supposed to look like. And all of this brings us right to the heart of the debate, where the scientific community has pretty much split into 2 major camps, each trying to make sense of these deeply strange clues. So on one hand, you have the natural explanation. Physicist Michio Kaku suggests that this is just a very, very weird comet, maybe an ancient one with a strange mix of materials that's causing it to break apart in an unusual way. But on the other hand, you have Avi Loeb and others pointing out that the data, the weird acceleration, the organized jets, is also a really good fit for a technological object using some form of propulsion. Dr. Kaku really represents the voice of scientific caution here. He acknowledges that you can't completely rule out an extraterrestrial origin, but the probability is extremely low. The default assumption, and the most likely one, is that we're just witnessing a natural, even if it's a highly unusual, cosmic event. But Dr. Loeb offers a counterpoint, and it's grounded in physics. He argues that advanced thrusters would be way more efficient than natural outgassing. They could produce that same powerful push using much less mass, which would neatly solve the size paradox and explain why the jets look so geometric and organized. And so, the race is on to solve this thing. And this isn't just some academic debate they can have for years. This is a mission with a very real and very short deadline because 3I/ATS is not sticking around. Now, to add a little more drama to the situation, there's been some frustration over delays in the public release of the high-resolution images and data. And of course, that kind of information vacuum has only fueled more speculation and made everyone even more curious for answers. This is the critical timeline. It's happening right now. Our most powerful tools, the Hubble and the James Webb telescopes, are getting their final, most detailed observations. December 19th is our best shot for a really clear look when it makes its closest approach to Earth. After that, it starts its long journey back out into interstellar space, and it's going to quickly fade away forever. So, what are they looking for exactly? Well, a few key things. First, can they actually see the fragments? If the Webb telescope spots multiple distinct pieces, the natural theory gets a huge boost. Second, what are those jets made of? The chemical data could reveal if it's normal cometary ice or something else. And finally, the biggest question, what if it's still a single intact object doing all of this?
You really have to appreciate what a unique moment this is. We didn't have the James Webb telescope when Oumuamua flew by. This is our first and maybe our only chance to study an object like this in real time with the best technology we have ever built. The opportunity is absolutely unprecedented, and it is incredibly short.
So in the coming weeks, we might get an answer that confirms everything we know about comets, or we could get an answer that opens up a whole universe of new possibilities about what or who is out there. Whatever the truth is, we have one shot to find it before 3I Atlas vanishes back into the interstellar void, taking its secrets with it.